Okay, so matrix question, right? So we've been given, first of all, transformation matrices question. So we've been told that a transformation matrix A describes a reflection in the line y equals negative x, followed by a rotation of 90 degrees anti-clockwise centered at the origin. Can we find that transformation matrix? Can we find that matrix A? So, any ideas?
We have like no value or something.
Okay. So I think the easiest way of doing this is geometrically, okay? So think first of all about just applying a transformation where nothing changes, okay? So the way which I need you to think about this is draw out a Cartesian axis, Cartesian grid like this, okay? And just think about your basis vectors. Now just remember, your basis vectors can be technically anything, but we tend to write them in terms of our component directions. So our x direction and our y direction. Don't worry about three-dimensional transformations. We don't worry about those in this course. It's not that hard, it's just an extension of this, but we only worry about 2 dimensions. So our basis vectors would be component directions. So if you think about it, we've only got x and we've got y. Think about combinations of moving left and right and up and down will get us to any point on this grid. That make sense?
Yep.
Yep. So my basis vectors then would just be 1 unit in each of those directions. So 1 unit in the x direction would be like that. So that would be 1, 0. Can you remember what that vector would be called if I move from the origin to the point 1, 0? Just 1 step in the x direction.
Unit vector.
Yeah, good. What letter do we give it?
Sorry?
So it is a unit vector because it's magnitude 1, perfect. Do we give it a special name because it's 1 unit in the x direction as opposed to any other direction?
Well, if you use the notation, it would be like I guess?
Good.
Magnitude? No.
That's all I'm looking for, just I. Right?
Okay.
So I is a vector which is 1 unit in the x direction. That make sense? Literally what we're just doing with our vector stuff, right? Okay, so once we've got that then, we'll also think about the component of the 1 unit in the component direction of y. So what letter would we give that? So that would be 0, 1. So yeah, what letter would we give that vector? J. Yeah. So we have I and J, right? I and J. Now, when we're thinking about these in terms of matrices, particularly transformation matrices, all we do is we create a 2 by 2 matrix, and we put I, or the coordinates of I, in the first column, so i.e. 1, 0, right? And we put it as a column, so 1, 0, okay, because it's a vector, right? And the second column of this matrix, we put the components, we put the coordinates of J, okay? So 0, 1. Now, does anybody recognize that particular matrix? So 1, 0, 0, 1. It is a special matrix. It's called I.
Identity.
Yeah, good, it's identity. Yep, I for the identity matrix. The reason being is because actually this is a transformation matrix, right? If I take a coordinate system and multiply it with this identity matrix, nothing changes. It's identical, right? Hence the reason why we say identity matrix. So because I and J haven't changed at all, I haven't applied any transformation, if I multiply with the identity matrix, nothing changes, hence it's just status quo, right? So all I need to do then, when I'm thinking about these kind of questions, is start off with this and then think about where I and J would end up when I apply each of these transformations and write the matrix down, okay? So if I do a reflection first of all in the line y equals negative x, well, this is this line here. Okay, so that's the line y equals negative x. So if you think about it, I start with I and J positioned here, and then I reflect them in the line y equals negative x. So first of all, can you tell me where I would end up when I reflect it in the line y equals negative x? So it was there. Where would it end up now?
Negative. 0, negative 1.
0, negative 1. Yeah, so this one here.
The other value you put.
Yeah.
Oh,
Does that make sense? Because it was there, it gets flipped over, so it's now down there.
okay.
Yeah. So that is new I. Right, that's my new I. Where would J end up?
-1, 0.
Isn't it new G?
No, that's still I because it was there. Okay, it was there. So if you think I was there, it then gets flipped over, so it gets face down there instead. Just think about your mirrors.
Okay. Okay.
Yeah? Okay, and then J, you said it was going to be...
-1, 0.
Yeah, perfect. So -1, 0 down here.
But when you stated the initial question, I was confused on the matrix. Like I didn't naturally think it was the identity matrix. So if there's no mention of what we're talking about, it's the identity.
If there's no transformations applied, it's basically just the identity matrix, right?
Alright,
So a transformation with no changes is the identity matrix, right? But obviously we're doing some changes, so we just think about where I and J would end up when we do those relevant transformations.
When I look at this question, transformation matrix A, which is okay.
Yeah.
But I didn't have it defined as that.
Okay.
I just had nothing.
Okay, sure.
0, 0, 0, 0. I was like, well.
Okay.
I kind of stuck because I didn't see any directional.
Yeah, exactly. So we always start with we need to move in the component directions, right?
Yeah.
So it can't just be all zeros, right? Because then we're not moving any directions, right? So it has to be the identity matrix we always start with, right? And then you think where I and J end up. That's the easiest way of doing it. Okay, so let's actually fill in the coordinates of I and J then in this new matrix. This is going to be my new updated transformation matrix. So I'm going to take 0, -1, that's my I, stick it in the first column. And then I'm going to take -1, 0, that's my J, and stick it in my second column. So this would be the transformation matrix, this matrix here, would be the transformation matrix that is a reflection of the line y equals -x. Does that make sense?
Yep.
Right? We're not finished though. We need to also do a rotation of 90 degrees, anti-clockwise, right? So all I can do is just take this, so take this I and J, and rotate those and see where they end up. So hopefully you kind of get the idea. Let me see if I can squeeze it in over here. Okay, so I gets rotated 90 degrees anti-clockwise. Anti-clockwise goes against the direction of the clock. Okay, so in other words, going sort of, towards the left. So where would I end up?
1, 0.
Perfect, back where it started, right? Just going to end up back over there. So I would end up at 1, 0. Where would J end up? So
0
what's that?
-1.
Good. Down here. There you go. Okay, so when I fill all that in, okay, my new transformation matrix, if you like, is going to be 1, 0. That's my I. And 0, -1, that's my J. Okay? So are you happy that actually that's everything I need, right? What I'm basically proposing then is that my transformation matrix A, which is all of these transformations put together, is just going to be that last one. So 1, 0, 0, -1.